index I is part of the hill in nums if the closest non-equal neighbor of I are smaller than nums of I. Similarly, index I is part of a valley if nums if the closest non-equal neighbors of I are larger than nums of I. Adjacent indices I and j are part of the same hill or valley if nums of I equals nums of j. Note that for an index to be part of a hill or valley, it must have a non-equal neighbor on both the left and right index. Okay. Return the number of hills and valleys. Okay, so some numbers could be the same as the next one. You ignore those. So it looks to your like 4 is a hill, 1's here at the valley, 6 is a hill. So there should be 3. This one, 6 doesn't have anything on the left of it. 5, 4, and 6 doesn't create anything. 4 doesn't create anything. 1 doesn't create anything, so there's nothing. Okay. I think this is appropriately easy. And I think I'll probably use, I could possibly use a deck here, but maybe I can just use single variables. So I just need to keep track of the last two uniques that are not kind of creating any streaks, and then the next one should, and then the third one should determine whether or not the middle one is a hill, valley, or neither. And then you kind of replace it. So if you have 2, 4, and then you see the 1 makes the 4 a hill because it's higher than the first and last, and then 4 and 1 becomes the things that you care about. So I think maybe I'll say it's like ABC. So A and B has to be the first 2 unique things there are. I could do 2 passes here and recreate the array as like an array of unique values, so I can then ignore any repeating values. That might not be bad. Okay, let's try that. Let's say it's uniques is an array for every value in nums. If the value, I think a unique should probably start with the first nums value. So for every value in nums after that, if value doesn't equal the last unique, then uniques dot append that value. Okay, then I can just say for every, and then I can say maybe what's the size of this thing? There has to be at least 3 values. If uniques is less than 3 values, then just return 0 because there's no way that you can create any hill or valley based on that. I'll say A and B is equal to uniques of 0 and uniques of 1. And then for every value in uniques past that, I'll say, I know that C is not going to be the same thing as B, so it's just if B is higher, if A is less than B is, I wonder if this works. I don't know. Can you actually do that? Does that work in Python? One is less than 4 is greater than 2. Does that work? Four is bigger than 1, which is bigger than 2. It's true. Okay, so yeah, sometimes I don't know, because that definitely doesn't work in like some other languages like Java, but and normally it doesn't. You don't really have that in normal presentation of math solutions either. Like that's not really a standard compound inequality or double inequality. So if A is less than, no, actually I need to say C is the last one. And I could probably reference value. So A is less than B is greater than value. That's the hill. Or if A is greater than B, which is less than C, that's the valley. And then A and B become B and value, or B and value is stored into A and B. Uniques is, should be the length of uniques, is less than 3. Yeah. Oh, C is value. Oh. Okay. Yeah, this is definitely, I don't think I've ever actually did a problem where I forced myself to do this sort of notation. I guess it works in Python. Note to self, if I can remember it. Okay. Summary, this is going to be, you don't have, there's definitely other ways of doing this. I mean, it's an easy problem, so kind of optional, or to kind of remove the need for logic that checks for duplication slash streaks of same value, can create a unique array that that appends value, that uses a for each loop and only appends the value to the array if the value differs from the last entry in the array. So that's this one, that's the uniques here. For every value after the first value, if it's not equal to the last value in the uniques array, and append, and then iterate, have two variables for the current, have two variables for the current start in the array, and use logic to determine if the middle value is a hill, valley, or neither. if hill, i.e. A is less than B is greater than C, or valley, then increment the answer count. Then update those values to readjust A, B, and C, I guess. So the A and B becomes B in value, where value is kind of the C. Time complexities can be O of n to create the uniques array based on the original array of values, and to iterate over that uniques array to count the hills and valleys. Base complexity, this can be O of n for the uniques array. This is optional. There are definitely other ways of doing this problem that avoids it and would use O of 1 space instead. This is just strictly based on the fact that I think it's just quick to do this, but you can definitely create logic that avoids circumvents this. It just needs to have maybe a for loop that iterates over the values and nums, and then there's a while loop that I guess you could use a while loop, or probably just an if statement that skips the current value if the value itself matches the last value. Like if the current value matches the B value, then skip it.